Hello, geometry students. This is 5-1 bisectors of triangles. This is part 1, I should specify. We can identify and use bisectors and perpendicular bisectors of triangles. So bisectors of triangles, there's bisectors we need to refresh our memory on. So a segment bisector is any segment, line, or plane that intersects a segment at its midpoint. So it cuts that segment in half, that segment bisector. So here's an example here. And then if a bisector is also perpendicular to the segment, it's called a perpendicular bisector. So this is what a perpendicular bisector looks like. Go ahead and take a moment to see what the difference is between the two pictures, between the segment bisector and a perpendicular bisector. You should notice it's that 90 degrees. So if we bisect at 90 degrees, it's a perpendicular bisector. Now here are two theorems you need to write in your packet from chapter 5, the first ones. So the perpendicular bisector theorem is saying that if a point on the perpendicular bisector, so that's CD, of a segment, then it is equidistant from the endpoints on that segment. So AC and CB then are equal. They're equidistant. So we can say these two are congruent then, if it's on the perpendicular bisector. Now the converse is, we're going to flip that around. So if the point is equidistant here from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if we know that they're equidistant here, then we know this segment right here is a perpendicular bisector. So pause the video, read this through, make sure you understand what these two theorems are saying, or the theorem and its converse is saying. Alright, so we're going to use these theorems for some practice problems. So we want to find AB. So notice AC is a perpendicular bisector because BC and CD are congruent. So since it is a perpendicular bisector, we can say that AB is 4.1 because of the theorem. Now let's find RT. Again, we know that RS is a perpendicular bisector. Then we know that these two are equidistant. QR and RT are equidistant from each other. So we can take 2x plus 3 equal to 4x minus 7. Let's go ahead and let's see, I'm going to subtract 2x. I'm going to add 7. I get 10 equals, 2x. I'm getting ahead of myself. Divide by 2. X equals 5. But I want to find RT, so I got to plug that back in. So 4 times 5 minus 7. That would be 13. Alright, we have another example here. We have two pieces. I'm going to go ahead and scroll down and move this down here. So find WY and XY. So here's WY. And we also want to find XY right here. So let's look at WY. Since these two sides are the same, we know that X is equidistant from this segment on either side. So then we can say, we're going to use the converse, that WY is going to be 3 here. But now we want to figure out what the distance is, or what the value is of XY. So how do you think we could do that? Well, we have a right triangle here. So we have to remember the Pythagorean theorem, which I believe you learned in algebra. So this is, we could say this is A, and this is B, and this is C, because the hypotenuse is always across from the 90 degrees. So we have 3 squared plus b squared equals 9 squared. And again, I'm using the Pythagorean theorem, a squared plus b squared equals c squared. So it looks like we have 9 plus b squared equals 81. We're going to subtract 9 from both sides. Okay, sorry about that. Had to go yell at my dog. He's getting up on the counter. 81 minus 9 then is going to be, if we subtract that, it's going to be 72. So we're going to square root. So b squared, or excuse me, b equals 72. Square root is 72. And remember, we can split this up into perfect squares. If you want to, well, I guess if you want to write it as a decimal, you can. But if you remember splitting up square roots, this is 9 times the square root of 8. Ooh, actually, you know what? There's something bigger, a perfect square. And again, if you want to use a decimal, that's fine. So we have the square root of 36 times 2. So b is 6 square roots of 2. And again, you can use a decimal if you want. All right. So after you watch this video, we want to do 1 through 30 all eventually. But after this video, you should be able to do this. Once you watch part 2, then you can do this whole page, which we'll be doing on Monday. Alrighty? Alright. You guys have a wonderful day, and I'll see you later.